purpose of this video is to give you some clues about how to handle the Standing Waves lab. And what you'll do first is you'll open up the lab manual in the lab, and you can read through this if you like. It's a fairly tough read, I must admit, but there is some interesting information, especially down here when we get to the harmonic waves. And what we'll be doing is we will be finding these standing waves, or that's what we're looking for. And what we'll be able to do is figure out a wavelength and also get a frequency. Now the wavelength of these waves is going to be, well, if we take this one for example, the wavelength would be from the top of this wave to the top of this one. So you see, even when we only have one of these, we're not seeing the entire wavelength. It's actually double this. And we'll get to calculating wavelengths a bit later. But what we're looking for are these harmonic standing waves, and the first one is going to look like this, sort of like a jump rope, and it's just going to be going up and down, but it looks like it's going to be standing still. And then we're looking for one where we've got 2, and then we're looking for one where we've got 3, then we'll look for one where we've got 4, and we'll look for one where we've got 5. And all of this is going to depend upon the frequency that we're oscillating the string at, and of course the mass as well. Alright, so let's look at what we're required to do. The procedure says that what we need to do is first of all turn on the oscillator, and then we need to use the course here to get up to 3, and we can use these buttons here to go up and down around the 3. Alright, so that's going to be our starting point, will be the 3. We need to put a mass on here, and I think they say to put 100 grams on here first, so we'll do that. And then what we need to do is adjust this frequency so we end up getting waves that look like what we see in the background. So we're looking for this kind of wave first. Now, from a practical point of view, what does that mean? Well, let's go back and look at the wave. It's going to be something where it's going to pretty much come almost all the way down to the ruler here. At the moment you can see that there's a bit of wave motion here, so this is not a true standing wave that we're looking at. So what we can do is we can adjust this, and we can adjust it upwards, and we can see what happens. It looks like it's getting worse now. So this is not really what we're looking for. You see how it's kind of flattening out? That's not what we want. So what we're going to do is we'll reduce this. We'll go a bit below 3, and we'll go down to about 2.7. As you can see, the situation's improving. This is coming down a lot more than it was. And we'll go down to 2.6. Yeah, let's see if we can do better. 2.5. That's probably about as good as we're going to get. So down here you can see that this is pretty much reaching the ruler, and that would be our first frequency for our first standing wave, will be 2.5. Now we're also asked to find out where the nodes are. Now the nodes are these situations here where the waves end up cancelling out, and there's nothing happening here. In this instance there is no node because effectively the ends are the nodes, so we don't need to worry about it for that one. As far as the lab results go, you'll be filling them out on your lab form in something that looks like this. But when you're doing your notes, what you'll do is you'll open up these notes over here, and you'll be able to type stuff in, and I'd recommend typing in similar data as to what you're going to see here. Obviously you don't have access to this until you've actually done the lab. A trick is you can always open the lab and then close it again, and then this opens. You'll be able to see the kind of data you'll have to put in, but you'll have to put data in your notes while you're doing this, and then fill out the form when you do the assignment. So going back to what we were doing here, we'll go back into procedure. Now I'll open this back up, and we write down our first frequency here for our first harmonic. That's F1, and that's going to be 2.5, and that's what it says on the oscillator. Alright, so the next thing we're going to do is see if we can get the situation that looks like this. Now the clue that they give you here is that these will occur at whole number multiples of the first frequency. So the first one is going to be at 2.5, the second one should be around 5, which is about double this, and then the third one should be 7.5, which is 3 times this, and the fourth one should be about 10, and the fifth one should be about 12.5. So let's go up to 5 and see what we're dealing with. Remember, what we're aiming for is something that looks like this, with these coming down pretty much to the ruler. So just keep that up, going up to 5. And there you go. As you can see, this is coming down pretty much to the ruler. So what I'll do is I will mark in my frequency here, and this one is going to be 5.0. Now the other thing that they're asking for here is the distance to the node. Now in the case of the first one, as I said, there is no node because it was the ends, but in the case of the second one, we can see a node, and it's right here. You can see it there. It's pretty clear, it's right there. And what we can do is we can actually measure that. And we just put our marker down here, we measure it, and you can see that it's at, well, let's zoom in a little bit so we can make that a little bit clearer. There we go. It looks to be about 92 centimeters. So that's what I'll mark down on my lab report. They actually want these in meters. Now to get the meters, you'll take the 92 and divide it by 100. So what would go in here is 0.92. So remember, to get from meters, some centimeters, which is what we're dealing with down here, into meters, we divide by 100, and that'll give us our value here. Alright, so now we're looking for the third one, so I will raise this up to 7.5 and see if we get something that looks like this. You can see it's beginning to come out now. It's not there yet. There we go, we're getting closer. Keep going, we're getting a little bigger than that. Get up to 7.5. It's probably not helpful. 7.5 is getting there. Yeah, I think 7.5 is probably about it. So we're getting something that looks like this. And I'll put that in my frequency here. And I will now measure the distance to the first node. So what we're looking for is this distance here. That's what the procedure is asking for. So I'll go ahead and get that distance, which is, looks to be around 59 centimeters, something like that, or 58. We'll say 58 centimeters. So that's what I'll put in here. Is 0.58 meters. Remember, I divide that by 100 to get my meters. So it's a 0.58. Now we're looking for the next one, and it should be around 10. So I raise this up to 10. And you can see we get something that looks like what we're supposed to see, 4 of these. And again, we can measure the distance here to the first node, and it's 43 centimeters, which is going to be 0.43 meters. Remember, divide that by 100. So I'll put that in here. Whoops. 0. It's not behaving. There we go. So 0.43 meters is what we're dealing with there, and that was on, it looks like 10 hertz. So I'll put down 10 in here. Alright, so now I will go for the fifth one, and that should be around 12.5. And we should be seeing something that looks like that. There we go. So looking at about 5 of them there. Don't know if we can get any better than that. We might be able to. We'll leave it at 12.5. I think we can pretty much see that it's 5 there. So then we can measure the distance, and it looks to be about, to the first node, around about 32, 31, well, we'll say 32. So that would be 0.32 meters. Alright, so I'll put 12.5 in here, and down here I will put 0.32 meters, or 0.32 meters. Alright, so that's how you're going to do it. Now obviously you're going to do this for masses where they're 200 grams, which would be 0.2, and then 0.6 kilograms, which is 600 grams. So you'll do 100, 200, and then 600 grams. The kilograms we get by dividing those by 1,000. So we get the 100 grams is 0.100, 200 grams is 0.200, and 0.600 kilograms for 600 grams. So you'll do the same thing. Just to give you a hint here, you're expecting some result here. It's I don't know. It's going to be. I'm not going to tell you exactly what it is, but I will say it's somewhere under 6, and this one here is going to be somewhere under 7. So that'll give you an idea about where to look for your first standing wave on each of those, and then you'll be able to figure out the rest of this based on what I'm showing you here. Alright, so that's all I wanted to show you for the lab part. Stand by for the calculations part in the next video.